Okay, so in OOP programming, there are some patterns. So we call it design pattern. Maybe C++. Design patterns and refactoring. There are many things related to this one. So, I remember that there are at least 32 patterns in OOP programming, and well, I'll show you an example of design pattern with a factory pattern. Okay, so we are doing this. We generate circle, box, and maybe we can define more objects like triangle and polygon and many things. Diamond. Well, we can define many things, but we don't need this. We don't like this one. Well, we can avoid this one. Maybe we don't need to include this one at all. We do not access the details of class circle and box at all. So it means that, well, maybe we don't need this one. But well, I'll show you step by step. Okay. So maybe we can do this. Maybe if we want to add a circle, we can do this. Or maybe we want to add box, right? So for this, maybe we can define on temp. This doesn't work like this here. So maybe we can add a temp pointer, right? And temp is a new circle, and add it to this list, temp. Okay, and temp is a new box. Maybe we can do this. You got it? And we can also use a for loop. Number we want push back. Just a moment. I don't like this mouse and keyboard. Okay, so we can do this. Well, we can generating this list automatically here, right? Okay. So what we need is this temp pointer, right? This pointer, and we can edit blindlessly. We don't need to know the real instance of this temp pointer. So we can define a function like this, geometric object. So create geometric, and maybe you can use a string. Name like this one. So we can copy this one like this. So if name is circle, maybe return new circle, right? If name is box, return do box or return null pointer. Maybe you can use switch case if you want. You can use it. You can use switch case instead of nested if. Okay. So create geometry object. So let's not use for loop for now. So go vector dot pushback and create geometry object circle maybe, and okay, it's working. String box so we can do this instead of doing this. Okay, so you got it? So you push back the pointer created by this function, and it received a flag. Well, you may use an integer or enumeration type here. Okay, so it's working. Let me rebuild everything. Rebuild solution. So it's working as usual. And absolutely, well, it'll be better to move this one to a different place. Maybe geometry object. Right? Okay, so let's see if this works, but well, it's not working because there is no instance of geometry object for now, right? So, and we know that we can use this function without instance. Well, there is no member to be used in this function, right? Okay, but at least we need to know circle and box class here. Just a moment. Circle, box. Okay, so in this case, we can define a static function. Okay, geometry object undefined. Where is it? This is not the thing we like. We need to move the body of this one to CP file. Add new CP file. Up. Okay. Let's move this one to okay, and remove the body, and it also means that you don't need to know the details of these classes here. But I'm not sure we can define static function in this way. Create geometry object not found. Oh, string is not defined. Include string. create a geometry object. Okay, so we defined a static function here, right? It's not working. So in this case, we can use it like this. And I think it should work. Yep. And compiler error. Let me check. Geometric object something. Oh, the class definition was. Can I prefer writing in this way? Okay, so we are happy now. Okay, let me rebuild everything. Let's run it. Okay, so it's working as usual. Okay, so let me explain more. So if you define a static member function, you can use it without defining the instance of this class. Okay, so because this member function does not use any of member variable or member function here. This is a static member function. It's a little bit complicated, but you can do this here. And one more thing you need to know is that this member function can be used to generate instances of box or circle or any other children classes, but it doesn't. The interface still doesn't know anything about box or circle classes. It's okay now, right? But instead, the CPP file includes circle and box. It knows about the details of circle and box classes. It's getting more complicated, but this is the beginning point of the advanced OOP programming. Okay, so yeah, create geometry object, returns new class and new box and many more the children classes, the pointers of children classes, right? So this is factory pattern. Actually, this is the factory pattern. So that we don't need to know details of the geometry object. So note that, well, the circle.h and box.h are included in geometry object class. Okay? But in source.cpp, the real part which uses the draw, it seems like this main function execute all of the draw functions, draw function of box, draw function of circle, and more. But we don't need this one here. You got it? Let's recompile and execute. It's working. Yeah. This is very important. It's very complicated. Well, it seems like this main function, this source.cpp file, is the real part to execute these draw functions. This one is defined in circle class. This one is defined in box class. So they do everything, right? This part uses circle class and box class, but they can do it. Oh, this part, but they can be executed without knowledge of circle.h and box.h. This one includes geometry object.h in this way, but it doesn't include box class or circle class, right? This is the abstraction, and we can do through this interface. This class behaved as an interface between the real executing part, the main function, and the children classes.